In this recording we're going to look at the bitwise exclusive OR. So I'm going to take two numbers, x, y and z, and again we'll just set some values to them. So I'll put 3 in here and I'll put 14 here, and so what I'm going to say is z, x, y. So we're going to exclusive OR those two together. Now x is a value of 3, which is 0, 0, 0, 0, 0, 0, 1, 1. Y is a value of 14, that's 0, 0, 0, 0. I'm trying to remember what 14 is. I think it's 1, 1, 1, 0. Okay, for 14. Let me just check that just to be on the safe side. So there we have 1, 1, 1, 0 for 14. Now, if I do an exclusive OR on these, remember with the exclusive OR that they must be the two inputs A and B must be different in order to get a 1 out. If they are the same, in other words, if they're both zeros or both ones, they will get a 0 out. So these are different, so I'll get a 1. These are not different, so I'll get a 0. These are different, so I'll get a 1. These are different, so I'll get a 1, and these are the same, so we'll get a 0, 0, 0, 0. Now that's left us with this number here, which is, let me see, 8, 12, 13, which is a 13, which, if we look back here, not too far. So 13 there it is there, or it's a D in hexadecimal. So let's try this program here. So again, I'm just going to save this as a new name. And so I'm going to put in the 3 there, and I'm going to put 14 here, decimal, and let's run that. It's going to print it out as hexadecimal, so it should print out a D for us, and it hasn't. So I obviously have some. Oh yes, I still have the OR in here. Sorry about that. So exclusive OR, which is just up above the C, or up above the 6 key. Okay, and we see 0xD written there. Or if I change that to decimal, %D, it'll print it out as the number 13, and we'll see it there as 13. Okay. Now where is this used? Well, again, and we'll have to wait until you actually see applications of this in embedded systems. But if I want to toggle some bit, so let's say I'm going to start with 0, 0, 0, 0, 0, 0, 1, 1. And let's say I choose that this is the bit here that I want to toggle. I don't currently know what it is. I don't care if it's a 0 or a 1, but whatever it is, I want it to change to the opposite. Well, what I can do is I can exclusive OR with this number here. Now we can have a look at that. We can see that that's a 1 and that's a 0 there. So that's what I'm going to exclusive OR with. And what should happen then is we can see these are different, so that's a 1. These are different, so that's a 1. These are the same, so it's a 0, a 0. These are different, so that gives me a 1. These are the same, the same, the same. And what we see is that this 0 has now changed to 1. The same would occur if I put a 1 somewhere else. Let's say if I put the 1 over here, then all of a sudden I'd have 2 being the same, and I'd end up with a 0 down here at this point. So therefore, whatever happens, I will actually toggle or change the state of one of the bits, but not the rest. That's where this comes in useful in embedded systems. What result will this give us here? This will give us a 1 and a 3, and that's in hex. So we'll just put that in there. So we have a 3 there, and this number is going to be 1, 0 in hex. So that's 0x %x. And that has come out as a 13 in hex. as we said it would. Okay, 13. Okay, so that's the bitwise exclusive OR.